right, guys, so we're going to do 11.6B hypothesis testing. This is going to be a lot more complicated than our confidence interval. As you can see, there are 5 steps to this process, all right? So I'm going to go ahead and show you those 5 full steps, and then we're going to specifically focus in on each one, all right? But I just wanted to show you just what it looks like, what's the end goal. This is what it looks like in its totality, all right? So here's our example. A sales manager claims that her representatives spend less than 5 minutes with each of their customers. Using a sample of 132 customers, the manager calculated a mean duration of 4.9 minutes, standard deviation of 0.6 minutes, test a hypothesis at 1% significance. All right, so your first step is to state the null and alternative hypothesis. All right, so null and alternative hypothesis. Typically, you want to put what you're trying to show as your alternative, okay? So we're trying to show that they spend less than 5 minutes with the representative. So that's why this inequality here is less than, okay? And this mu, this is the population mean. So the true population mean, less than 5 minutes is what we're trying to show. So typically I actually write this one and then I go back up, and your null hypothesis will just be the equal to version of it. All right, so null hypothesis is always equal to. Okay. Your alternative hypothesis can either be less than, greater than, or not equal to. Those are 3 options for your alternative. All right, so read the problem, see what you're trying to prove, see what you're trying to show, and make that your inequality. Okay, questions on step 1. Okay, setting up your null and alternative. And yes, you do have to label which one is which. So make sure you label HO for null, HA for alternative.
Can we just write null and alternative?
No, I want you to use the symbols. Yeah, use the symbols, it's faster. All right, step 2 is to find what's called the Z statistic. The Z statistic. So these variables should look similar, right? This is very, very similar to what you saw with our confidence intervals. Same players in this formula. All right, we still have our sample mean. This one is our population mean. All right, and this is going to come from the null hypothesis. All right, from the null hypothesis. The S is going to be your sample standard deviation, and N is still your sample size. All right, so same variables as your confidence interval, just this one we get from the null hypothesis for population mean. All right, so in this example, right, just basically plugging that all in, right, they gave you this sample mean of 4.9. This 5 is where this 5 came from, the null hypothesis, right? Divide by the sample standard deviation over the square root of the sample size, and calculator, you get negative 1.91, right? So that is your Z statistic for this sample. All right, so this just tells us that, hey, this sample is 1.91 standard deviations below the mean, all right? If this null is true. So we want to see how unusual that is. Okay, so step 3, we're going to find the p-value. All right, so what is the p-value? The p-value is a probability. All right, so first, knowing it's a probability is good, because if you get a p-value of like 3, you might be on the wrong track, okay? You don't get a probability of 3%, maybe, but not 3. So it's a probability. So probability of what? This is the probability of this sample that you got, right? The probability of this sample if the null hypothesis is true. All right, so the p-value is the probability of the sample if the null is true. So this is how you calculate that. We are going to use our normal CDF. So we're going to say, okay, my sample to the left of that. And that area is your p-value. Okay? The reason why I'm going to the left is because of this alternative hypothesis. All right? If it's less than, I want the area to the left. If this was greater than, then I would want to find this area to the right. Okay? We'll talk about not equal to in another example. But that direction of shading is dependent on your alternative hypothesis. Okay. So because we're going to the left and we want to find that area, I'm going to do normal CDF of a small number, like -999, up to the z, -1.91, standard deviation of 0, and 1. That's our standard normal distribution, and that is our p-value right there. All right, so the probability of getting this sample, or less, is about 2.81%. All right, so what do you guys think? Is that likely or unlikely? It's not really likely, right? Like 2.8%, but that's why they give us kind of like a threshold here. They're saying, all right, my significance level is 1%. So what that means is they're saying anything above 1%, we're gonna say is okay. It's still not weird enough. It has to be under 1% for it to be considered weird enough. All right, so we're gonna go ahead and look and compare at the significance level and the p-value. By the way, that significance level has its own variable also, and that is alpha. All right, so alpha is the significance level. And for the most part, at least in this textbook, I think they give it to you in the problem, but just in case they don't, the default is 0.05. So just in case the textbook doesn't give you a significance level in the problem, 5% is that threshold. Okay? All right, and literally all you're doing is just comparing which one is greater and which one is less. So check out the p-value, check out the significance level. Which one's bigger? P-value, okay. So that goes into step 4, all right? Step 4, you reject or fail to reject based off of that comparison. So since the p-value is greater than the significance level, it wasn't weird enough, all right? You fail to reject the null hypothesis. That wording is very particular, all right? You fail to reject the null hypothesis. You do not accept the null hypothesis. You just don't have enough evidence to reject it, okay? It's like when you go to court of law, right? When the jury stands up, it's not like, we have proven Kevin innocent. No, right? It says the jury has found the defendant not guilty. There's a difference. Proving somebody innocent versus not having enough proof to prove them guilty, very different. Okay? Very different. It's like, I don't know, asking somebody to prom, right? Like somebody saying emphatic yes or just not replying. Well, they didn't reject you, right? But that's not the same thing as saying yes. It's different. Anyway, so yeah, if it's greater than, you fail to reject, which means step 5, there is not enough evidence to suggest the alternative hypothesis. All right, there's not enough evidence to suggest that the average time representatives spend with their customers is less than 5 minutes. All right, so that's your general structure for step 4 and 5. If it's greater than, if the p-value is greater than the significance level, you fail to reject the null hypothesis. There is not enough evidence to suggest this alternative hypothesis. Okay? Hypothetically, if it was less than, all right? Hypothetically, if the p-value was less than the significance level, then that sample would be weird enough for you to say, hey, this sample is super unlikely to happen if that null is true. All right, so because of that, I'm going to reject the null hypothesis. Right? You have the sample in your hand. You can't say the sample is not true. It's there, okay? It just means your initial assumption of the null hypothesis thus must not be true, all right? Or it's it's very unlikely for both to coexist. That's what the p-value is, right? That they coexist. Alright, so since the sample is definitely true, you have to reject the null hypothesis if your p-value is less than the significance level. And that means that there is enough evidence to suggest that the alternative is true. Okay. Again, notice the wording is pretty particular here. To suggest, right? We didn't definitively prove it, it's just one sample, but it's enough evidence to suggest that the null is rejected, therefore the alternative is taken. Okay, and those are literally your only two options. It's either the one printed or the one in parentheses. Those are your only two options, nothing else. Okay. All right, you guys, that is a full hypothesis test. Any questions?
Oh my God.
All right, let's break it down. I know that's a lot. So let's go ahead and focus on these first three steps. All right, so let's focus on the first three steps. Let's flip to the back, actually, and focus on just the calculation part and kind of get that handled. Okay? So number 3, test each null hypothesis at 5% significance. So that's our alpha. Then we're just going to write reject or fail to reject. Okay. So they give you this null hypothesis. They give you this alternative. That's step 1, already done for you. Let's go to step 2 and find that z statistic. All right. So z, I'm going to go ahead and take that sample mean of 12 minus my null hypothesis mean of 11.7 divided by the sample standard deviation of 1.5 divided by the square root of n, which is 100. All right. If you plug that in, you actually end up just with 2. Yeah. All right, so 2 is your z statistic. All right, let's go ahead and find now your p-value. So your p-value, we're going to do normal CDF. And I'm looking at this alternative being greater than. So because it's greater than, I'm imagining my sample being out here. And I want to find the area to the right. So I'm going to do normal CDF of 2, 999, 0, 1. All right, and that ends up giving you 0.023 for your p-value. All right, how are we doing so far? Okay. All right, and then the last thing then is to compare it with your significance level. All right, so your significance level here is 5%. Your p-value is 0.023. So your p-value is less than or greater than? Less than. So do you end up failing to reject or reject? Reject. All right, so since this p-value is less than your alpha, you are going to reject your null hypothesis. That means your sample was weird enough for you to question that null hypothesis. All right? If your sample was very likely to happen, then you're like, all right, I guess I'll take it. All right, I'll keep it. But if your sample is weird enough, then it makes you question the validity of your null. Okay. Number 4, I want to show you this one because it has this not equal to there. I'll show you guys what to do with that. All right. So for number 4, same thing. We're going to go ahead and find the z since our null and alternative, step 1, is already done. All right, so our z, we got our sample mean of 150, population mean of the null hypothesis at 151.3, sample standard deviation of 4, divided by the square root of sample size of 150. All right, that ends up getting me negative 3.98. All right, I trust you guys can type that into your calculator yourself. Okay, p-value. Let's go ahead and check out what to do with p-value when it is not equal to. All right. So because it's not equal to, we want to go on both sides, right? It's not single direction, right? Not greater than, not less than. So we're actually just going to go on both sides that looks like. All right, so we got our z of negative 3.98. I want the area to the left of that, right, going away from the center, but I also want the area to the right of the positive version. Okay, so the combined areas, that's going to be your p-value. That's going in both directions. So how do I find that? Different ways to do it. If you were just to do normal CDF with negative 999 to negative 3.98, what would you just need to do to this answer to get both of these? Double it. Yeah, it's the same area, so just double it. Okay. And then you have both. Okay. And if you were to type that into your calculator, you would see like 6.88 something something something. Don't leave your answer like that though, right? P is a probability. So what must be at the very end of that calculator line? E something. This is scientific notation. It would say E negative 5. So just make sure you write that in scientific notation. Please don't just give me a p-value of 6.88. Okay? And this ends up being a very low p-value. So what do? Do we fail to try or reject? Reject, yeah. So the p-value is less than alpha, so we're going to reject the null hypothesis. I mean, this is like super, super unusual, right? Right. Very unlikely for your sample to happen if the null is true. Because it's so unlikely, I'm going to reject the null. All right. Cool. Why don't you guys try, just do number 5. Try number 5 on your own. See if I can do it. All right, here's the answer for number 5. All right, we got a z of negative 2, p-value of 0.046. So you ended up failing to reject the null hypothesis. All right, any questions on that? Okay, just in case you did number 6, that's what that would look like in case you did number 6. All right, this ended up having a super low p-value, so you ended up rejecting the null hypothesis. Okay, let's try the whole thing now, you guys. Flip back to the front. Number 1. Let's do all the steps. Here we go. Number 1, it says a marketing manager wants to create an advertisement for a new phone stating that the user can surf the internet for more than 24 consecutive hours before the battery needs to be recharged. The quality control department takes a sample, I'm gonna start labeling stuff, sample of 163 phones and calculates a mean time of 23.6 hours before the battery needs to be recharged, standard deviation of 1.2 hours, test the hypothesis at 5% significance. All right, let's do it. So step 1, write your null and alternative hypothesis. All right, so when you write this, you gotta label your H sub O, your H sub A. Okay. I usually start with writing my H sub A. I want to test to see if it's true, that it's more than 24 consecutive hours. So I want to see if that average mean is greater than 24. Right, that population is more than 24. Your null hypothesis is just going to be the exact same thing, just with an equal sign. Always an equal sign. Okay. All right, that's step 1. Questions on that? All right. Step 2, this is finding that z value. All right, so plug in all your stuff. You get 23.6 minus the 24 from the null hypothesis. Sample standard deviation of 1.2. Sample mean, or sample size of 163. All right, that ended up getting me negative 4.256. And I plugged that into my calculator. All right, step 3 is finding that p-value. All right, so p-value gonna be, I'm gonna look at this greater than. So I wanna shade to the right of that. Alright, so I'm gonna do normal CDF negative 4.256 to positive 999.01. Alright, so the idea is that here's my sample. I'll find this here. So that's gonna be big. Alright, that's gonna be a big p-value. In fact, it ends up being 0.9999. So very likely to happen. Alright. So because of that p-value, are we going to reject or fail to reject? Fail to reject for sure. Alright, so that is step 4. Alright, so in words, since the p-value is greater than the significance level, since the p-value is greater than the significance level, I fail to reject. Yes, you do need to use those very specific words. I fail to reject H sub O, the null hypothesis. Okay. Feel free to use the symbol, as long as the meaning is clear. Alright, and then step 5 is where you input the context of the problem. Alright, so since the p-value is greater than the significance level, you fail to reject the null hypothesis. That means there is not enough evidence to suggest, and then here's where I kind of reread the problem. And I'm like, okay, what is my alternative in the context of the problem? So the alternative is saying that the new phone, you can use it for more than 24 consecutive hours. Right. So there's not enough evidence to suggest that the average battery life of this new phone is more than 24 hours. Right. To suggest that the average battery life of these new phones is more than 24 hours. Okay. Alright, so notice that this is basically the alternative in the context of the problem. Alright, questions on that? Ocean, yeah?
So the greater the p-value, we're trying to prove that the alternative way of finding this is stronger.
Yeah, we're trying to see if we have enough evidence to say the alternative is true. So we're assuming the null is true until we have enough evidence to say otherwise.
So if it's higher than the significance value, then the alternative is wrong.
Then you don't have enough evidence to say the null is true, and therefore the alternative is false. I think I said that right, I'm not sure. But yeah, and if this was, let's say hypothetically, if this was less than, the only thing you would have to change, actually the only thing you would have to change if the p-value was less than is you would change this to less. You would just say reject, and you would not say not. Alright, so if the p-value was less than, that's the only thing you would have to change. Everything else would stay the same. Okay. Alright, you guys got it? Ready to try? Yes, try it. Alright, number 2, all on your own. Give it a shot. Okay guys, let me go ahead and show you the answers for number 2. Now that you've gotten a shot at it, here it is. Alright, so number 1, the null hypothesis is mu is equal to 7. Please do not forget to write that mu there. Alright. Alternative, we're testing Megan's hypothesis, so this is going to be greater than 7 here for the alternative. Alright. Do make sure you label your HO and your HA clearly. Alright. Number 2, your Z statistic was 8.944, and the p-value, I did normal CDF from this value to positive 999, and I got a 1.9 times 10 to the negative 19. 19 like your calculator says, write it out as your scientific notation. All right, so super, super low p-value. So since the p-value is less than the significance level, you reject the null hypothesis. There is enough evidence to suggest that their true average time to run 1 mile is over 7 minutes. All right, so make sure you guys have that context in there in that step 5. All right, but the average run time is more than 7 minutes. All right, any questions from trying it on your own? Not too bad after, yeah. Once you break it down, it's not too bad. All right, good job, you guys. Let's go ahead and give you back your test.